Thank you for the invitation. Right, so we are going to do a duo today. So I will start the presentation and then Graham will talk a bit more about the details and then I will come back to end the presentation. So a few words first about who we are. So we are researchers from the Information Retrieval Group of the University of Glasgow. Essentially, we are a large group of researchers working at the intersection of information retrieval, recommender systems, and natural language processing. And we build essentially intelligent technology that connects people to information. So we work on the foundations of information retrieval, machine learning and the likes, but we also work on some specific domains, healthcare, technologies, and also sensitivity review, which is the object of our work today, right? So I think that we have been talking a lot about archives, right, and about sensitivity, and the talk is related to sensitive information within archives. So the documents, as we have been now talking for a day, can come in different forms and shapes, right? They can. This is an example of a government document, but they can be also annotated with some handwriting. They can come in the shape of emails, and we have done work, for example, to look at identifying sensitivity across multiple emails. So for example, you can see an email by itself. It may not be sensitive, but if you put it within a thread or link it to other emails, it will become sensitive. So we look at that, identifying this kind of essentially sensitivity within a set of emails. And of course, sensitivity can come within commercial documents, agreements, and the likes, right? So let me tell you a bit about our journey in working in this domain of sensitivity or sensitive review. So it's actually good to be here because that's where it all started in 2013 when TNA approached us with this problem that already is now also mentioned in the scoping document, which is the fact that the amount of digital-born documents is increasing phenomenally, right? And they approached us to work on a possible solution. That is back in 2013, right? And at that time, we had a one-year project with TNA, but also archivists and other people from the University of Glasgow, and also across a number of networks, right, on archives. And we had some money to work on technology-assisted sensitivity review, right? So it was mostly about developing classifiers to help identify sensitivities in documents, right? And then a couple of years more, Graham McDonald, who is now here, started actually a co-funded PhD with TNA, with the National Archives, on developing classifiers for sensitivity reviews, right? And then we were involved with SVGC, which is a kind of small and medium enterprise that works for government departments on the problem of sensitivity review. So we had a bit more funding to try and develop the Graham thesis into a product, right, for the FCU. And then we had a number of other smaller projects, right, and where we transitioned essentially our research into real products, right, to work on the sensitivities archives of the FCU, right? So there were a number of projects, including a KTP project of a couple of years, where we really refined a bit the technology-assisted sensitivity review that we have been working on from 2013, right? And essentially, after that, we moved a bit like our domain, and we moved a bit towards more AI-powered technologies, right? So Iadh Narvala joined us to do a PhD, and he worked on identifying information threads or sensitive information threads within emails, right? Recently, right, we started developing that technology a bit further towards what we call sensitivity-aware search, which is what we are going to work on, what we are going to talk about today. And Jack McKinney is working on a PhD on this topic, right? And I think Graham will cover a lot of the details about this, right? So first, let's try to put the work in context, right? So the difference between sensitivity review and sensitivity-aware search, right? So sensitivity review, as most of the people in the room know, is something that is legally mandated by the government. So that means we need to check that anything that we put in the public has gone through a sensitivity check, right? So we have worked a lot on this since 2013, right? However, as mentioned in the scoping document, the fact that the number of documents, the digital-born documents, is now really huge, and it is increasing at a phenomenal pace. So essentially, the problem is not really anymore the number of requesters, right, to that information, but it's actually the scale of the documents that we need to deal with. This is why we moved to another technology that actually was initiated by the University of Maryland, right, which is called sensitivity-aware search, right? So here, this is a technique that is complementary to the classical sensitivity review that archives have to undertake, right? So essentially, it's a technique that also can nicely coexist with retrieval augmented generation systems, because your archives can be actually non-sensitive, and you can believe that everything there can go to the open. However, when you use AI, for example, a retrieval augmented generation, and you try to generate a response, right, to a user query, the fact that the system will put that in context might actually generate sensitivities that were not in the single documents, but they are essentially, it can be derived from the context, from the answer of the AI system, right? So you can also see this sensitivity-aware search as a pipeline, very much similar to what we discussed yesterday about these sieves, right? These kind of different stages where the human intervention can happen at any stage, right? So it allows a kind of more flexibility in tackling the sensitivities within archives, right? So essentially in sensitivity-aware search, the search engine aims to maximize relevance while minimizing the likelihood of returning sensitive information, right? Or generating a response as part, for example, of a RAG system that might actually leak some sensitive information. And I think that Graham is going to talk a bit more about what we have been doing in that.
Perfect. Thank you. So it's very nice to be back. Thank you very much for the invitation. As he had said, the journey began at TNA since we've been here, so it's very nice to be back. So thank you. So in recent years, search as a field has gone through rapid advances, due obviously to the advances in large language models and other sort of AI-powered technologies. So today's search engines really are capable of sort of interpreting complex information, doing much reasoning, and processing the information to really come up with sort of understanding of what the information is or what knowledge is within the information. So, as he had mentioned also, you know, we're now, the RAG paradigm is very common, and this notion of sort of using search as sort of grounding generated responses within real records is a very important concept as well. So the search pipeline is becoming more and more important as these technologies develop. So we really have gone through a paradigm shift in search. You know, traditionally, when you're used to using your favorite search engine, it really was just sort of search as retrieval. You've got a collection of documents, you're putting in a search query, and it's just retrieving whatever documents the search engine thinks is relevant. However, nowadays, we really are today in an era of search as understanding, where we're really wanting to try and, the engine really wants to try and understand the meaning or the knowledge within that information. As Jason outlined yesterday, we are moving now into an era of agentic AI-powered search, where you've got lots of different tools, as was outlined in the scoping document, where you've got new protocols coming online, where you have individual AI agents working together, and we'll go back to talk a wee bit about that at the end of the conversation. But today, I'm going to focus on just outlining some of the technologies that we've sort of developed, sensitivity-aware technologies, within the retrieval pipeline. So traditional or modern retrieval pipeline, as has been alluded to already, is very similar to this notion of sieves that was highlighted in the scoping document. So what we've got is, we have some user, they can input a natural language query into the search system. That search system can ingest a whole collection of documents, maybe with or without sensitive information within it. But the idea is that if you have intelligent components within this retrieval pipeline that are sensitivity aware, the idea is to filter out the sensitive or high-risk documents as you go through. So we have a sort of simplified pipeline where we've got a first stage retrieval, which is a very lightweight ranker, which can be deployed over the entire collection. And its real purpose is a sort of high recall task where you're got maximizing the number of relevant documents, but filtering out as many sensitive documents as possible if it's sensitivity aware. So each stage of the retrieval pipeline, you're filtering out the set of candidate documents, so it gets gradually smaller and smaller and smaller. And as these set of documents that you're working on get smaller, you can then apply more complex, more expensive, more intelligent models to this smaller set of documents, so you can keep the efficiency throughout the system. And obviously then the sort of top ranked documents are returned to the user. And this user could be an end user, it could be a sensitivity reviewer. There really is opportunity within this pipeline to have sensitivity interventions at each stage. So here we outline the sort of four main stages in the diagram. You see that it's bookended by sensitivity classification. So this is the stuff that we've been working on originally for the sort of technology-assisted review task of sensitivity review. But here, obviously, you can just apply sensitivity classifiers at any stage in the pipeline, but traditionally it would be at the start of the pipeline or the end of the pipeline. What we're going to focus on today is these two components in the middle. So the first stage retrieval and the re-ranking component. So the first stage retrieval is a lightweight ranker that filters out most of the sensitive documents, then a more expensive re-ranker that's focused on re-ranking documents so that any high-risk documents are pushed down to the bottom of the ranking. Okay, so just going to take each of these components in turn, first stage retrieval and then the re-ranking, and tell you a little bit about them. You'll notice in the first stage retrieval here, we've called it a sensitivity aware learned sparse retrieval. Now, I'm not sure how many of you are familiar with learned sparse retrieval, but I'll tell you a bit more about that as we go. Okay, so as an overview, the sensitivity aware search pipeline has a number of benefits. Efficiency, you can have lightweight models applied to the entire large collection, and gradually as you filter out more and more documents, you can have more expensive, intelligent models that are applied to smaller sets of documents. This means you can also have specialization at each stage of the pipeline, so you can have a sort of very broad notion of sensitivity maybe earlier on in the pipeline, and then later on you can have very specific and tailored approaches that are targeting specific types of sensitivities. And this layered approach also mitigates the risk within the system. So you can mitigate the risk of individual errors from individual models. Okay, so let's talk a wee bit about first stage retrieval. It's a lightweight retriever that retrieves a candidate set of documents from the full collection. So this notion of learned sparse retrieval, basically it's a sort of state-of-the-art industry standard approach. There's a range of different types of models, but it's almost like the best of both worlds. It combines the term matching, lightweight sort of index structures of traditional retrieval models, but it also integrates contextual semantic understanding from embeddings, such as BERT embeddings or such. So what we want to do is we want to be able to train these models, which are traditionally focused purely on identifying relevant information. We want to be able to train these models to also be able to filter out sensitive documents. What we want to be able to do is want to assign low importance to context sensitive terms so that documents that contain these types of terms are not included in the candidate document set. The reason we can do this with learned sparse retrieval is that the actual model itself has got individual context-aware embeddings for each term within the corpus. And so a document and a natural language query can be made up of individual importance weights for each term within that specific context of that search. One of the main real advantages of this, especially within a sort of sensitivity review or a sensitivity environment, is that it means that the models are completely interpretable. We've got importance term weights for each term in the collection, and we can actually work out what the model is thinking about when it's making decisions about what's sensitive or not. So here we see just a wee example. Here we see that we've got a sensitive document which is talking about someone's complications during pregnancy. The model is learning that this notion of personal complications is sensitive. We have two models. On the top, we have a relevance-only model, and in the bottom, we have the sensitivity-aware learned sparse retrieval model. You'll notice that both of these models are based on SPLAID. SPLAID is an industry standard model which is widely deployed. So these models are sort of easily adaptable to the sensitivity-aware search scenario. So here we see the darkness of the colour represents the importance of the term that the model has learned. So the sensitivity-aware model manages to identify that the specific term fetus, for example, is closely related to pregnancy complications, and therefore it learns that this term should not be weighted highly. Even though it's a relevant term, it will downweight the importance of that term so that it's not actually returned in the final result set. It's also able to know that other medical terms such as pulmonary, although they're medical within the same sort of context, they're not actually related to the sensitive topic of pregnancy complications. So we can really sort of investigate what the model is learning and what the model's thinking, which is obviously very important within the understanding of sensitivity review. This is just showing a few results of how these models perform. So the two models that this paper is actually still under review, so it's just been submitted, and basically on the x-axis we have the number of sensitive documents that are returned within the candidate set. So going along to the left-hand side is better. You've got fewer sensitive documents. And on the y-axis, this is greater relevance. So at the top, higher number is better, basically. So we want to be in the top left-hand corner, basically, where we've got lots of relevant documents, but very few or almost no sensitive documents. So anywhere on this sort of Pareto frontier means that we're getting the best trade-off between maximising the relevance for users and minimising any sensitive information. You see that both displayed distill and displayed SANS. The distill and SANS are just two different approaches that we propose for actually training these models. But the point is that they manage to optimize that trade-off between relevance and okay, so that was the first stage retrieval. A quick look at first stage retrieval. Now let's look at the re-ranking. So remember, the re-ranking is a more expensive model which only works on a smaller subset of the documents that have been retrieved through the filtering process. So the good thing about that means that you can deploy much more what we call expensive models. But basically what that means is that you can spend a lot more time training them to have a much more in-depth view of specific types of sensitivities. One of the particular models that is particularly good for this kind of task is a cross-encoder. I'm not going to go into the details of the cross-encoder. I'm sure a lot of you are probably familiar with it, but the fact is that these models learn, they take a natural language query and the document together within the training process and look at the two of them together within the context, so they can really learn a an understanding of the interaction between that natural language query and a particular document. So you can get a really fine-grained representation of what sensitivity might be. So in this paper, we just proposed a number of training strategies. Basically, in a traditional cross-encoder model, when you're training it, it's a single objective. You're learning what relevance is. However, for sensitivity-aware search, it's a bi-objective task. You have to be able to teach the model at the same time what relevance is and also what sensitivity is. So you have to come up with some way of fitting this sort of bi-objective task into the natural sort of linear training scheme. So what we do in this paper from Cigar in 2024 is we propose 3 sampling strategies that enable us to sample particular documents so that we can show the model the representation of sensitivity that we're interested in having it learn. The key component to the way these models are actually learned is what we call hard negatives. So basically, a hard negative is just when you're training the model, you're going to give it a query and you're going to give it an example of a relevant document. And that's what you want it to learn, the relevant document. But when you're learning relevance, what you would naturally do is just give it an example of a non-relevant document as well, so it can learn the difference between relevant and non-relevant documents. You don't want to just take any non-relevant document. What we typically do is we take what we call hard negatives. So you can use a different lighter weight model, the traditional models such as BM25 or something like that. Give the query to that model and get a ranking of documents. Hopefully you'll have some relevant documents at the top, but as soon as you go down that ranking, the first non-relevant documents that you come to, the first mistakes basically that model makes are obviously the documents that are most similar to relevant documents but are actually non-relevant. So they're difficult. So by giving these difficult examples, the model can learn a really intricate representation. What we want to do is we want to be able, instead of giving it this non-relevant document, we also want to include this notion of sensitivity in it. So we propose 3 different strategies for learning how you can sample. What we actually do is sample relevant sensitive documents along with non-relevant documents, so that we just change the sort of training scheme slightly such that you're training it on the query plus a relevant non-sensitive document and then a relevant sensitive document, so that it can learn that real intricate sort of borderline between what is and isn't sensitive. And here we're just quickly showing you some results. Obviously on the x-axis we've got our 3 proposed strategies. On the y-axis we've got this trade-off between relevance and sensitivity. So the metric is actually called sensitive NDCG. It's not really important. What's important is, again, we're looking for this trade-off between relevance and sensitivity. We want as many relevant documents as possible. We want as few sensitive documents as possible. So we have a relevance-only baseline and a post-filtering baseline. So this is just the cross-encoder trained for relevance, and then you put a sensitivity classifier on at the end of it. See that all of our approaches managed to outperform the relevance-only baseline, so we're actually improving over a straightforward cross-encoder, and the majority of the approaches actually perform better than the filtering approach. So even without putting filtering on, you're still getting benefits. But the beauty of the sort of cascading pipeline is obviously that your benefits can accumulate. But ultimately, what we're looking at is users are presented with relevant documents, while sensitive documents are protected from exposure. Any high-risk documents, when they're in the re-ranking stage, are pushed down the ranking so that they're below the cutoff of what would actually be shown to the user. Okay, so here we're just going to outlining the fact that it's a pipeline that you can put safety interventions at any stage of the pipeline. In the top 2 rows, we've got sort of relevance-only baselines, BM25, and a relevance-only learned sparse retrieval. The metrics that we're looking at, NDCG at 10 just basically says how many relevant documents are there in the top 10 documents. Sensitive documents at 10 is how many sensitive documents at 10, and what we're really interested in is the third column, the cost-sensitive NDCG. This is the trade-off between relevance and sensitivity. So if you look at just by adding a sensitivity-aware learned sparse retrieval, so this is just putting the one model in as the basic first stage retrieval approach, we're already getting benefits over relevance-only approaches. You can still get extra gains from putting in this re-ranking component at the end. Even with a relevance-only re-ranking component, we're still improving performance because obviously the relevance is improving. But if we have a sensitivity-aware re-ranking approach at the end, we're also benefiting in the sense that we're reducing the number of high-risk or sensitive documents. So there's cumulative benefits from adding sensitivity interventions at each stage of the pipeline. Okay, so that's a quick sort of tour of some of the approaches that we use. In order to be able to sort of develop and evaluate these tools or approaches, we really need test collections that are suitable to be able to teach the models what is sensitivity, what is relevant in this context. So I'm just going to outline very quickly a new resource that we've developed recently and we've just made publicly available. This is just in press, actually. It's going to be published at SIGIR this year. And it's basically, we call it SARA, a test collection for sensitivity-aware search. So obviously training these models takes lots and lots of data. So in order to be able to train these models, you need to be able to give it lots and lots of examples of what it is you want it to be able to learn. So there are a few test collections publicly available that have been used for sensitivity-aware search. However, they all have some kind of limitations or drawbacks. Either they're only available under strict licensing agreements, which can make them difficult to obtain and difficult to work within teams with. They're either expensive to purchase, or if they're freely available, they're typically very, very small collections, and they usually have proxy sensitivity. So having a collection where you've got real life sensitivities, which is publicly available, is obviously challenging. And that's a key component to what we need in order to be able to develop these systems. So obviously a freely available collection was needed to be able to hopefully advance the field a bit. So that's what we did. We looked about and saying, okay, where can we start? What can we do? I'm sure a lot of you will be familiar with the Enron email collection. It's been around for many, many years now. We looked at that and we decided this is probably a good starting point for developing this collection. Why? So a test collection for sensitive research, it needs to discuss a wide range of topics. Some of those topics at least must have sensitive information related to them, real sensitivities. And it has to be diverse and freely, easily available, so there's a low barrier to entry, so anyone can work in it. The Enron email collection was a collection of business emails from the Enron company that went bust. And there's been a number of different releases. There was one of the original releases was around about 600,000 emails. There was a secondary release which was done by MIT, where they labelled 1,702 emails for a range of different classification categories. So we've got 53 categories. The collection has gone through several iterations, so it's a stable collection and it's freely available. So it satisfies our needs. However, there's no queries available with it, and there's no relevance assessments for queries. So, and it's only 1,702 labels, emails that are labelled. So we need to obviously extend the collection. So what do? We start with the 1,702 emails that have the classification labels. We have to identify topics and create queries. From those queries, we need to then get relevance assessments. So we did a series of crowdsourcing studies for this, but this enables us to create a test collection where we can then train an LLM as a judge, so that we can learn what relevance is, and we can label the full collection for relevance. We still need sensitivity labels though, so we can start with the emails that have been labelled by MIT and create a sensitivity classification test collection. This enables us to build a sensitivity classifier and get sensitivity labels on the larger collection. So what did we end up with? We end up with a collection. We identified 50 topics. We crowdsourced 10 query formulations per topic, and we end up selecting the three sort of diverse sound sort of queries per topic. And we have relevance judgments on the original 1,702 emails, and we can use this to train a LLM as a judge approach. We use in-context learning, following best practices from the literature to make sure that we're, giving a good representation. And what we end up with is 50 topics, 3 queries per topic, and we've got 130,000 documents actually labelled. And the plot just shows you the sort of distribution of sensitive documents within each topic. So roughly speaking, average topic will have about 10% sensitive documents or so. So it's the minority class, but it's realistic. How do we get the sensitivity labels? Like I said, the MIT version of the corpus labelled the subset of emails for a range of classes. 2 of those classes, so purely personal and personal within a professional context, are obviously very well aligned with sensitivities that have been discussed yesterday and within the scoping document. So we select these as our sensitive classes or sensitive labels, but all the other sort of labels are usable as well. So we train a T5 classifier, and it's got a 0.86 accuracy, and then we predict the sensitivity of the rest of the labels. So hopefully what this amounts to is a usable collection, which can hopefully help to facilitate open source development within this field. We release a number of artifacts, so we've got dense and sparse indices that are ready to use that can be downloaded. We also get all the raw files of all the crowdsourcing studies, and everything's available through GitHub. And the most important thing is it's really easily usable. So within PyTerrier, you can do your first experiment within about 20 lines of code. And with that, I will hand back to Iadh quickly.
Yes, I think a couple of slides. I know that Liz is trying to make us finish. So I think we cannot not finish without talking about agentic workflows and agentic search, right? So I think that Jason yesterday presented a way to use agentic search for sensitivity review. We have been working on this kind of agentic workflows for a couple of years now. I think that as the scoping document itself highlighted, users these days are really expecting conversational systems. Nobody is really going to sit, type keywords, and then expect to see links to documents. I mean, this kind of era is gone. People really expect to see responses. They expect to see something generated as a result to any of their actions. We have been working on agentic workflows for a couple of years now, not for sensitivity review, but also for fintech, for healthcare technologies, for discovery, scientific discovery, and the likes. And the idea is this. So you can imagine that you have your user, it could be the reviewer, right? Or it could be the end user, right? And then you have an infrastructure that has agents. An agent essentially is a functionality, right? It could be an AI functionality, but it could be also a traditional, let's say, functionality. And the idea is that these kind of agents are coordinated through the MCP protocol, which allows to also audit these various functionalities. And essentially, these kind of agents work together to assist the reviewer in completing a task, right? For example, sensitivity review, right? We can also have explanations, we can have provenance, we can have, even like our colleagues from yesterday, the cabinet office, they were talking of a knowledge base, and you can do reasoning with the agents on this kind of knowledge bases, and you can explain the results. So this is the kind of things that we are working on now for a couple of years for different tasks, right? And we believe that it could be also used for sensitivity review, like Jason showed yesterday. So like everybody else in this room, we are really open for collaborations and for, essentially for joining efforts on any of these kind of interesting tasks, right? So we are open essentially for such collaborations. I wanted just to thank our colleagues who have been working with us on sensitivity review in particular. Tim Gollins has been a TNA member actually for many years, and then he worked at the University of Glasgow for a couple of years before he moved to the United States. Graham McDonald is still a professor at the University of Glasgow, and the other three are Heath, Erland, and Jack, who have been doing PhDs and the likes on sensitivity review. Thank you very much.